In this video, we will discuss about one more example. This example is from William Hayt book, and this is also a practice problem. You can find solution from here. You have only answer in the book, and this is how you have to solve the circuit. And in the previous problem, we saw that initial voltage was given, but in this problem, we do not have any initial voltage that is mentioned in the problem. But we want to find out what is Vc of t at t equal to 0 and at t equal to 160 microsecond. So at first, we need to find out what is the initial voltage, which means t less than 0, because there is no initial voltage in the given problem. So how to find out? So at t equal to 0, kindly note this, the switch is moving here. So before the t equal to 0, which means t less than 0, the circuit is connected to here, not this side. If that is the case, this is the circuit. Okay, to find out initial voltage. Got it? Now we are going to find out what is the initial voltage across the capacitor, and we know that for DC capacitor is open circuit, so this will be open circuit like this, and when there is open circuit, the 70 ohm will not vary, so all the drop will be across the open circuit only. So Vc also 50 volt, which means Vc of 0 or V of 0 is equal to 15 volt. That is your initial voltage that is present in the capacitor before the switch is moving here, from here to here. T less than 0, the value capacitor or the voltage across the capacitor is 50 volt, and after moving switch from here at t equal to 0, how the discharge happens and what is the actual value at 160 microsecond. Okay, so when the switch is moved here for t equal to 0, this will be the circuit available, because this will be open circuit. So we have only 8 and 2 microseconds for finding the rate at which the stored energy 50 volt discharges. And here only one resistor, one capacitor, so R equivalent, which means RC value can be calculated 80 into 2 into 10 to the power minus 6, that is equal to tau value, and tau is equal to 160 into 10 to the power minus 6. Either you can keep 10 to the power minus 6, or you can keep 1.6 into 10 to the power minus 4. Either of the way we can calculate. Okay, so here we are going to calculate Vc of t. Vc of t is equal to V0 into e power minus t by RC. Okay, that is what we derived from the derivation. So Vc of t is equal to initial voltage 50 into e power minus t divided by 1.6 into 10 to the power minus 4. Okay, so 50 into e power, if you calculate this 1 divided by 1.6, you will get 6250 t, and if you apply t value is equal to 160 microsecond and calculate the value over here, this will be minus 1, and e power minus 1 value we calculated around 36.87 value, right? So that value appear here, and when you multiply 50 into this value, you will get 18.39. It shows that at 160 microsecond, as we saw that there is a graph that is going decaying, that value if you calculate at 160 second, the drop from V0, the drop from V0 of the drop V0 from the top position to that goes down, and at 160 microsecond you can calculate it is 18.39. If you want me to show it clearly, I'll use PowerPoint. Where is PowerPoint? Yeah. And you can see here. So the graph that starts from 50 over here and starts decaying like this to 0 approximately at 5 tau. And if you want to calculate what is the value at 160 microsecond, then somewhere here it is around 18 voltage from 50 to the value changed into 18. This is what the discharge rate that tells us from the given problem. Okay, now you look at this. So from 52 we have got 18.39 voltage at the rate of e power minus 6250 times of t value. So this is a William Hayt example problem, actually practice problem, and you can find a solution like this.